know many of you. Maybe you guys.
Hi, Mrs. Hamby. You guys can come sit down. There's plenty of seats.
Hello. All right. So you guys are studying wavelengths, right?
Yes.
No, yes. Sound waves, things that move in this kind of direction. So what is color? When you hear that word, what do you think? Red, white, blue, okay?
Nice. That's a good answer. I like that.
As artists in the room, what is color?
Artists, she's asking you.
John?
Or just the artists standing in the back trying to disassociate themselves from the scientists.
The paint thing, okay, I did bring some paint. So yeah, we think about maybe paints or dyes or the colors of actual things, right? Even the English language, we use adjectives before we describe something, and so it's a property of the object, like we might think about a red apple. However, the interesting thing about color is that color comes from light. And so when you see white lights, I think you guys would know that that contains all the different colors of light, right? So this little picture here is not actually a red apple. It's an apple that absorbs all of the light except for red. And it reflects red back into our eyes. And what the color actually is this small little area on the electromagnetic
Spectrum.
spectrum. Thank you. My science geniuses in the back there will help me out.
That's right. Reagan's in there.
So it's this small area on that spectrum that includes infrared, ultraviolet, actually this way, ultraviolet, X-rays, and then what's really interesting to me as an artist is that it also includes microwave and radio waves. So there's waves that we can see, that's light, and then waves that we can't. So objects reflect the color light. We normally think of it, like I said, in terms of paint colors. So, artists, what are our primary colors?
Yellow.
Oh, thank you, art historians in the back.
Oh, so smart.
Okay. So, am I painting with yellow paint right now?
Yes.
No, you're painting with every color besides yellow.
Yes, I'm actually painting with every color besides yellow. Or I'm painting with paint that absorbs every color except yellow. Okay, what is another primary color? Red. Okay, same thing. All right, and another one, primary? Blue. Now, I didn't bring another paintbrush, so this is going to mix a little bit here. There we go, we got some blue. All right, now how do we get all the other colors? Yeah, we mix them. So we use these primary colors. And how would we make green? Red and yellow makes green?
They're physicists.
God help us.
On the brush I added some yellow, and now I have, and you can even see it kind of mixing there, streaky. And I should have brought another brush, because now I can't actually do orange.
I have plenty of sinks.
Oh, that's all right.
Okay.
So, as I mix more and more paint colors together, though, what happens? You do get black. And why are we getting, I just mixed it right in the middle here. No, I do not have black paint. I just mixed it. It's actually a little bit blue. Okay, so physics-wise, what's happening here?
It's absorbing all of them.
All right, yeah, we're taking these paint
Good
colors
job,
that
Jeff.
absorb parts of the spectrum, and we're adding them together,
It's a black hole.
okay, to create something that subtracts all of the colors. Okay? So, that's one way of thinking about color, and that's how artists normally think about color, is mixing these paints together. Another way of thinking about color is actually thinking about the light that we use. Now, all of our devices, all of our screens, this projector uses light, right? And we see colors here. Have you ever looked really close at an older TV screen?
Mm-hmm.
What do you see? Yeah, you see pixels, and you can see little colored dots, right? Do you know what 3 colors those are?
Yellow, yellow, and red.
Yellow, blue, and red.
Did you guys ever hear RGB screens?
RGB. Red, green.
Exactly. It's red, green, which really surprises us as artists because we were taught that yellow is the color. So red, green, and blue are the 3 colors of light that we can use to create almost all colors you see on a screen. Now, have you heard of those TVs that have a 4th color?
Yellow.
They have the yellow, yeah, and they actually can get a little bit more colors. Now, I just tried this out in our classroom, and it didn't work. So I'm going to show you a video of what it's supposed to look like when you add these colors together.
The color wheel in light uses additive mixing the primary colors of red, blue, and green to mix to white.
And so you can see when you put blue and green together, what do you get in the middle there?
Like an indigo? And
Yeah, it's called cyan. It's a really,
Sky blue.
really bright light blue.
Let's get this one down there, as you can see right there in the middle. We call this a full spectrum.
Okay, so now we can see with that color wheel, if we add red and green together, what do we get?
What's in between your,
Yellow.
yeah.
Yellow. And if we add red and blue together, what do we get? Yeah, violet or
Cyan?
magenta. And
No.
if we add all the lights together, what's reflecting back? White. So that's basically how color works. It works one way if you're using inks or pigments or dyes, and it works another way if you're adding light together.
So, which one was additive and which one was subtractive?
This one is additive because you're adding the light together.
Okay.
When you're using paint, it's subtractive because you're subtracting the light out
It's
of.
absorbing it all.
It's absorbing
Okay.
the light from the object.
Isn't that also why, when it's on hot date, you decide to wear white clothes instead of black clothes?
Yeah, this is something that my historians just brought up. If you're wearing black clothes and you're out in the sun, your clothes are absorbing all the light and the radiation, the heat. And if you wear light clothes or white clothes, it'll reflect, so it's supposed to keep you cool. Supposed to.
All right, give it up for Ms. Hamby and the art students! Woo-hoo!